Hello, welcome to video as part of the video series on current electricity. In this video, we are going to go through some work examples on Ohm's law, series of parallel circuits. So let's look at the first example. Here we are told that the resistance of 30 ohms, a resistance of 30 ohms is placed in a circuit with a 9-volt battery. What is the current flowing through the circuit? So how do you solve this? First, let's list out what we have. We have the resistance as 30 ohms, and we have the voltage as 90 volts. We have to find the current, I. Okay, so what do? We apply Ohm's law. From Ohm's law, V equals IR. Because we are looking for I, we can make I the subject of the formula. So we divide both sides by R, we have V over R. So if you replace V with what you have, 90 volts, and R with what you have, 30 ohms. So that will give you what? If you cancel this, and this will give you 3 amperes. So that's the current flowing through the circuit. That's quite easy. Then we have another example. A current of 5 amps flows through a lamp when it is connected to a 110 volt source. 110 volts is the voltage source. So what is the resistance of the lamp? Here we have the current as 5 amps, and we have the voltage as 110 volts. We have to find the resistance. From Ohm's law, V equals IR. This time around, we want the resistance, so we make R the subject of the formula. In that case, we divide both sides by I. So if you do that, I divided by I, R will be V over I. So we replace V with 110 and I with 5, then you get the value of the resistance. 110 divided by 5. So that should give you 5 in 2 and 2. 22 ohms. Okay. That's quite easy. Then we have another example. Now here you have to calculate the total resistance in each case. The first one, you have resistors in series. So the resistance between these two ends, A and B, is what you are looking for. So because we have series connection, the total resistance RT will be equal to R1, if this is R1, and this is R2, and this is R3. It's going to be R1 plus R2 plus R3. And that will give you 2 plus 1.5 plus 2.5. 2.5. So that will be equal to 1.5 plus 2.5 will give you 4 plus 2, that's 6. 6 ohms. So 6 ohms is the resistance, the total resistance between A and B. Then second question, you have a parallel connection there between these two ends, because you can identify a junction here. So it means that these two resistors are connected in parallel. So 1 over RT, if you remember the formula for the resistance in parallel, will be 1 over R1 plus 1 over R2. So if I call this resistor R1 and this resistor R2, so it means I'll have 1 over 6 plus 1 over 6. And that will give you 2 over 6. So that means 1 over RT is 2 over 6, which is 1 over 3. So 1 over RT is 1 over 3. It means that R3, we cross multiply, RT will be 3 ohms. So that's the total resistance there. Okay. Then we have the next question. The next question we have a 5 ohm resistor in series. So I quickly do that. You have 5 ohm here. You have 3 ohm here. And you have 3 ohm here. And that is connected to 1 ohm here. So to solve this, we need to first identify the connection, whether it's series or parallel. So here, these two, they look like we are in series, but these two are in parallel. So when you do, I light the ones in parallel in red. So if I combine these two resistors, so the parallel one, let's say I get RP, that's the resistance for the parallel ones. Then I'll combine that with the series one. So this, in that case, when I do the RP, I will have something that looks like this: 5 ohms, 5 ohms. Then the RP will be here, and the 1 ohm will be here, 1 ohm. So this will be RP. Okay. So first, I'll have to do the parallel connection first. Once I get the resistance for the parallel connection, then I'll just add it to the series ones. So how do I get RP? The parallel ones. Then 1 over RP for the parallel part should be equal to 1 over 3 plus 1 over 3. So 1 over RP should be 2 over 3. Then if you cross multiply, RP will be, the 2 RP will be 3, and RP will be 3 over 2, which is 1.5. Okay, so 1.5 ohms is RP. So now I have RP. I can combine everything. So if I combine the 3, this is for the parallel part. Now I can replace RP as 1.5 ohms. So the total resistance, RT, will be 5 plus RP plus 1. So RT will be 5 plus 1.5 plus 1. So RT will be 7.5 ohms. Okay. And the last one, you have total, we have resistors in parallel. You have this 2 ohms in parallel with 3 ohms and in parallel to 4 ohms. Okay, so this is 2, 3, and 4. So the total resistance, 1 over RT, because this is parallel connection, will be 1 over R1 plus 1 over R2 plus 1 over R3. So if this is R1, this is R2, and this is R3, then I can replace R1 with 2, R2 with 3, and R3 with 4. So 1 over RT will be equal to 1 over 2 plus 1 over 3 plus 1 over 4. So the LCM should be 12, and this should be 6 plus 4 plus 3. So 1 over RT. So this will give us 13 over 12. So 1 over RT should be 13 over 12. So the cross multiply, 13 RT will be 12. Divided by 13, divided by 13. So means RT should be divided by 13. RT should be 12 over 13. Over 13, that should be 0. 0.1. 12 and 130, that should be 9. 12 times 9. No, 8. Huh? 13 over, it's 12 over 13, sorry. Not 13 over 12. 0.9 approximately 108. So approximately 0.9. Okay. So the last one, you have this connection. You have two 4 ohm resistors in parallel, and that will be in series with this 1 ohm. So you have to calculate the current flowing through the circuit. So the current will be this, which is to go like that. Now, first, we calculate the total resistance, because for us to calculate the current, we need Ohm's law. So V equals IR. Remember, this R is the total resistance. So I will be V over RT. So I need to get RT. 2 resistors in parallel. If I do the parallel first, I will have 1 over RT equals 1 over 4 plus 1 over 4. Then 1 over RT will be 2 over 4. We will cross multiply 2RT equals 4, then divide this by 2, then 2RT will be 2. So as a shortcut, if you have just 2 resistors in parallel, just use this formula. RT is product over sum. So R1, R2 over R1 plus R2. So that will make life easy. Product of the resistors 4 times 4 over sum 4 plus 4. So that's 16 over 8. So that will give you 2. So that's, you see that we got the same thing. So 2 ohms. So that will be in series with this. So RT is RP, let me call it RP, the parallel one, and I'm not to confuse you. P. So RT will be RP plus the 1 ohm. So RT will be 2 plus 1, which is 3 ohms. Now I have the total resistance, so I can calculate the current. I, that will be V over RT, and that will be V, what is V? 12 divided by what is RT? 3. So I will be 4 amps. So that's the current. Okay. Then the last example, you have this circuit and you have to determine the ammeter reading. So the ammeter reading basically is the current that is flowing, because the ammeter will read the current. You have 2 resistors in series. If this is R1 and this is R2, then it means that the total resistance will be R1 plus R2, and R2 will be 4 plus 2, which is 6 ohms. Now I have RT at 6 ohms. I can calculate the current. I will be V over RT from Ohm's law, and that will be 3 over 6, which is 0.5 amps. So I have the current at 0.5, which is the first part. And the second part says calculate the voltage across the 2 ohm resistor. The voltage across the 2 ohm resistor. That's basically IB. So the voltage across the 2 ohm resistor, voltage for 2 ohms will be the current that is flowing through the 2 ohm multiplied by the voltage, multiplied by the resistance of the 2 ohm, R of the 2 ohms. So the voltage across the 2 ohm resistor will be equal to the current that flows through the 2 ohm resistor multiplied by the resistance of that resistor itself. So the voltage for the 2 ohm resistor will be current that flows through it, because this is a series connection. The same current will flow around. So the current that flows through this 4 ohm is the same as the current that will flow through this 2 ohm resistor, and is the same as the current that will flow through the ammeter. So that means I2 ohm is still 0.5 multiplied by the R, which is 2 itself. So it means that the voltage across the 2 ohm resistor will be 1 volt. Okay. So now that's this, if we connect a voltmeter here, this will read 1 volt, which means if we connect a voltmeter here, that should read 2 volts. Why? Because when you add the two together, it must give you the total voltage here. And you can verify that quickly by calculating the voltage across the 4 ohm resistor. V, 4 ohm, should be current through the 4 ohm multiplied by the voltage, multiplied by the resistance of the 4 ohm. So, and that will be, what's the current? 0.5, and what is the resistance? 4. So 0.5 times 4, that should give you 2 volts. So you can see 2 plus 1 should give you 3. So, which is the total voltage there, okay? So we stop there, and I'll see you in the next video. Okay, bye-bye.